assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this example, we want to determine what the induced current is in this circular loop of wire, given that we have a current that sits directly over the center of our loop, and that current is decreasing with time. So we could say delta I over delta T is negative. Okay, so if we want to figure out the direction of our induced current, right, we need to figure out how the flux is changing in our loop here. So let's look at the direction of the magnetic field from our current here. If we point our thumb in the direction of our current, as we curl our hand around, our fingers should point in the direction of the magnetic field. So remember, for a wire loop like this, our magnetic field is going to curl around it, right? So actually, depending on what side of the wire you're on, will determine the direction of the magnetic field. So if you're on the top side over here, we can determine that it will be pointing into the page, again, just by the right hand rule. And then on the other side, you curl your hand all the way around to where it's upside down. Your palm should be pointing straight up. And if you have your fingers curled a bit, they should be pointing straight up as well. We can see that the field will be pointing out of the page on the other side. So since half of our loop has a flux into the page and half of it has a flux out of the page, and they're equal in magnitude, the net flux in our loop is actually always zero, whether or not our current is decreasing. So flux is always zero because the contribution from each half of our circle cancels the other out. So if that's the case, if there's no change in flux, since there's no flux at all, we can say there are no induced currents. And of course, if there aren't any induced currents, we can't talk about the direction of our currents. So there you have it. We just showed that the induced current is zero for a wire of decreasing current sitting over the center of a circular conductive loop.